You have to understand that late 1944 was an absolutely bizarre time to be rolling out a brand new experimental locomotive because Baldwin Locomotive Works was standing with their back against the wall, and the water was coming up fast around their ankles. The company had already crashed into bankruptcy in 1935 during the Great Depression, and if you look at the numbers between 1940 and 1948, you can watch steam locomotive sales literally evaporate from 30% of the entire market down to a miserable 2% by the end of that period. Baldwin had already thrown a lot of effort into Pennsylvania Railroad's duplex locomotive program, starting with the S1 in the late 30s and then the T1 in 1943. Those machines developed a reputation for chronic slipping and high maintenance at exactly the wrong moment in history. By the time 1949 rolled around, Baldwin's own history admits there was basically no demand left for new steam locomotives in the United States, and the company was scrambling to keep its steam and coal business alive. It took one last big swing on turbine technology, and together with its successor Baldwin Lima Hamilton, ended up building a small fleet of experimental coal-burning steam turbines for railroads like Pennsylvania, Chesapeake and Ohio, and Norfolk and Western. Not a single one of those machines worked out the way they had hoped. The S2 was their most ambitious shot, and it would fail spectacularly in front of everyone watching. Baldwin teamed up with Westinghouse Electric to adapt marine turbine technology for railroad use, because Navy battleships and destroyers had been running on steam turbines for years, and those systems made them faster than anything else on the water at the time. The engineering logic made perfect sense when you think about it. A turbine has way fewer moving parts than a traditional reciprocating steam engine, and it can convert energy much more efficiently without all that hammering and pounding you get from pistons and connecting rods. They designed a direct drive system where the turbine connected straight through gears to the middle two driving axles at an 18.5:1 ratio, and side rods carried the power out to the outer wheels on both sides. Wartime material shortages changed everything about the original design because they could not get the lightweight steel alloys they wanted. The planned 484 wheel arrangement had to become a 686 configuration when the extra weight from heavier steel meant they needed bigger leading and trailing trucks to support everything. Number 6200 became the first and only locomotive ever built with a 686 wheel setup in railroad history, and this beast tipped the scales at over 500 tons, spread across 122 feet of total length. The really weird thing about the S2 that nobody expected was the sound it made when it came rolling past you, because instead of that familiar chuff-chuff rhythm you got from every other steam locomotive on the planet, this machine made a powerful whoosh that sounded like something from a science fiction movie about the future. That forward turbine was spinning at 9,000 revolutions per minute and cranking out 6,900 horsepower, while a smaller reverse turbine generated 1,500 horsepower for backing up at speeds up to about 22 miles per hour. The whole propulsion system achieved a mechanical efficiency of 97%, which meant only 3% of the steam energy got wasted in the drivetrain, and that number was genuinely impressive compared to conventional locomotives that lost way more power through all their reciprocating machinery and valve gear complications. Pennsylvania Railroad put number 6200 into service, pulling some of their most prestigious passenger trains between Chicago and Crestline, Ohio on a 283-mile route that included the Broadway Limited, the Liberty Limited, the Trailblazer, the General, the Manhattan Limited, and the Golden Arrow. The locomotive also hauled military troop trains during the war and occasionally pulled express freight consists when they needed the extra power. On March 30, 1945, the railroad staged an official demonstration run. The S2 pulled a 17-car passenger train with a dynamometer car attached, and they ran that consist at 110 miles per hour for 30 miles on level track between Fort Wayne and Chicago, with engineer Flea Cartwright and fireman M.E. Brown at the controls. A British locomotive engineer named E.S. Cox rode in the cab during one of the high-speed runs and later reported that the locomotive maintained and exceeded 100 miles per hour for 12 consecutive minutes. That was truly remarkable performance for any steam locomotive at that time. The whole thing looked incredibly promising when the S2 was running at high speeds above about 30 miles per hour, because the turbine was spinning in its optimal range and consuming less steam than a conventional reciprocating locomotive would have needed to match that power output. Once you got above 40 miles per hour, Baldwin's own brochures claimed the S2's tractive power at the rail beat a 6,000 horsepower diesel-electric lash-up, and around 70 miles per hour, the turbine was running in its sweet spot, where the whole system finally started to make sense. Westinghouse engineer Harry C. May designed an innovative fluid pressure control system, which was granted U.S. patent number 2,515,962. It controlled starting, running, reversing, power output, and speed limiting in both directions, using just a single control lever in front of the engineer's seat. Without any computer technology at all, they managed to coordinate 2 separate turbines and 4 smokestacks that opened selectively as speed and load increased. That was genuinely impressive mechanical engineering for 1944. The problem showed up immediately when the S2 had to run at low speeds or operate in yard service, because steam turbines need to spin at a specific speed range to work efficiently, and below about 30 miles per hour, this machine turned into a coal-eating, water-guzzling monster that burned through fuel like crazy. The boiler normally ran at 310 pounds per square inch of pressure when everything was working right, but at low speeds that pressure could drop all the way down to 85 pounds per square inch when the turbine was gulping steam faster than the firebox could generate it. That massive fuel consumption at low speeds made the firebox run way too hot and ended up breaking stay bolts that held the boiler together, which created serious maintenance headaches and safety concerns that got worse over time. The real killer was that Pennsylvania Railroad had mated a completely conventional fire tube boiler to this advanced turbine system, without making any modifications to handle the massive steam demand and voracious appetite for fuel that turbines naturally have, and that design compromise turned out to be a fatal mistake that doomed the entire concept. In July 1948, the S2 made its final public appearance at the Chicago Railroad Fair alongside a T1 duplex, a huge centennial show on the shore of Lake Michigan, where more than 2.7 million people came to see nearly 40 railroads put their best hardware on display. It was called the last great railroad fair, and even Walt Disney showed up there to get inspiration for the steam trains he would later put around Disneyland. August 1949 brought the end, when number 6200 suffered severe turbine damage that would have cost way too much to repair. With maintenance costs climbing steadily, the railroad stored the locomotive at Crestline and Altoona until they officially retired it in 1952 and scrapped it the following year. The locomotive had run only 103,000 miles in about 5 years of actual service, which was pathetically short for a machine that cost that much money and generated that much publicity. The really bitter irony of the whole S2 story was that Lionel Corporation got so excited by all the publicity from the locomotive's 1944 debut that they rushed to make toy replicas numbered 671 and 2020, which went on sale in 1946 while the real locomotive was still running. Those toys sold far better than the actual S2 ever performed, and Lionel kept making new versions like the 681 model even after the real locomotive had failed and been stored away. Baldwin's steam turbine program never produced a single successful design, despite building 5 different experimental turbines for various railroads, and by July 1948, Westinghouse had to buy 21% of Baldwin's stock just to keep the company alive long enough to pay off their debts. Baldwin merged with Lima Hamilton in 1950 as a last desperate move to stay in business, and they stopped building locomotives completely by 1956 when there was simply no market left for what they were selling.